right, 6.2 notes. How do you rationalize the denominator when it's not a square root? Some of the sections feel a little bit tough. We'll talk about how to do that. First it says simplify. Write the answer in simplest radical form. Okay, so the first thing we're going to do is use our properties, which you had on your paper. Obviously, they show up here. But the first one is when you have the same base different exponents and you're multiplying, you want to add the exponents. Okay, but to add the exponents, what we want to do is change them to have the same denominator. So 1/2 we can rewrite as 2/4. 1/2, 2/4 the same. So now we can add those and do 1/4 plus 2/4, and that gives us 7 to the 3/4. Should be your answer. Now it says to write it in radical form, so now we can rewrite it. Remember the root goes. Let's keep going down here. The root goes, the bottom number is your root, so it'll be the 4th root of 7 cubed. Okay? And then we can simplify that and write 7 cubed as, what is 7 cubed? 7 power 3. 343. I should have known that. Okay? So 343. So the 4th root of 343. And that'd be the simplest way to write that radical. Okay? Let's go to the next one. We got the cube root of 4 and the square root of 4. Now, for me, it's easier to just write it in rational form and then rewrite it. Okay? So that's what I'm going to do. I'm going to rewrite this in rational exponent form as 4 to the 1/3 times 4. Remember, there's no number right there. It's 2, so it'll be 1/2. Okay? Again, what I want to do is make them have the same denominator. What's the least common denominator of 1/3, 1/2? Is 6. So I can change this to 2/6, which is the same as 1/3. And I can change this to 3/6, which is the same as 1/2. Now to have it like this, I can add the exponents. 2/6 plus 3/6 is 5/6. So I have it as 4 to the 5/6. Then I can rewrite it in radical form. So bottom number is 6. So it'll be the 6th root of 4 to the 5th, which 4 to the 5th power is, what is 4 to the 5th power? I didn't write it in there. Let's see what it is. 4 to the power of 5, 1024. Okay, so I'd have the 6th root of 1024, and that's how I'd write my answer. Okay. And actually, I guess, write your answer in simplest radical form. All right, another way I would accept the answer is, let's rewrite that. I would accept either way. We have the cube root of 4 times square root of 4. Well, square root of 4 is 2. Okay, so you can write it as cube root of 4 times 2. Technically, this would also be acceptable as an answer. Okay, so either way works. If you can simplify the radical, do it. If not, then keep going. Okay, like on A, you cannot simplify 1/2 or 7 to the 1/2, 7 to 1/4. Okay, but on this one, you can simplify square root of 4. So let's just do that and write it as 2 cube root of 4 instead of 6 root of 1024. Okay. Either way, I would accept either answer on this one. Okay. Let's go to the next one. Okay, when we divide, we have to subtract the exponent, so we have, remember that's a 1 right there if it's not written. So we do 1 minus 1/3 because we subtract the exponents. Well, 1 is 3 over 3 minus 1/3 gives us 2/3. Okay, and then we can rewrite that as the cube root of 5 squared, which equals the cube root of 25. That's how you write that in its most simplest form. Okay, so that's how you solve that one. When you divide, you subtract. Okay, let's go to the next one. a couple different ways on how to do this one. What I did is, and this isn't the only way you can do it, but what I did was I rewrote it as 20 over 5. Since they both have a power of 1/2, you can rewrite that 1/2 right here. Okay? And kind of write that out. You can readjust, because we know that the 1/2 is out here. You can rewrite it like this, right? Okay? So we're just doing the opposite and taking the 1/2 out. Then what I do is 20 over 5, which is 4. So I have 4, 1/2, and on the outside I still have that 3. Okay? Then what I would do is I would just do what's inside first. 4 to the 1/2 is the same thing as square root of 4. Well, let's just rewrite. Let's do power over power. We can multiply these together. So we have 4 to the 3/2 right now. Okay? Because you can, when you have power over power, you can multiply those together. So if I rewrote that, okay, it would be the square root of 4 cubed, okay? And the square root of 4 cubed is 64, so we'd have the square root of 64, which just equals 8, okay? Could have done that another way too. You could have done 4 to the 1/2 is 2, and then 2 cubed is 8. There's a bunch of different ways you could have got the 8, but the main thing is that you get 8 at the end. One thing you need to remember or keep in mind is that 9 to the 1/2 is the same thing as square root of 9. If something's to the 1/2, it's the same thing as the square root of that. So when they have 4 to the 1/2 right there, you can automatically write it as 2. Okay. So a bunch of different ways you can think about that. Kind of got to use some creativity and use your properties on that. But basically, if they have the same exponent, you can move that exponent out and simplify from there. Okay. All right. So on these ones, we're going to simplify right there, simplest route form. So we got 12. What we're going to do is 12 is not a perfect cube, and 18 is not a perfect cube. But if we multiply them together, 12 times 18, we get 216. And 216 is a perfect cube, so then we can just do that. The cube root of 216 is 6. Okay. On the next one, 80, there's no 4th root of 8, there's no 4th root of 5, but we can rewrite it as 4th root of 80 over 5, which 80 over 5 is 16, and the 4th root of 16 is 2. Okay, so that's how you simplify that one. Cube root of 104. 104 is not a perfect cube, but it has a perfect cube factor of 8. So we can rewrite it as the cube root of 8 times the cube root of 13. The cube root of 8 is 2. There's no cube root of 13, so you can just leave it as 2 cube root of 13. So the same rules apply. Like when we simplify square roots, you got to be able to simplify cube roots. That's why it's important to have that perfect cube list that we made, that perfect 4th list, that perfect 5th list. Same thing with 250. 250 is not a perfect cube, but 125 is. And 125 times 2 equals 250. So then the cube root of 125 is 5, so I can rewrite it as 5 cube root of 2. And that's how I write that. Okay. So that's how you have to do those. You have to use your properties to break it down or split it apart. Make sure I had all this right. Okay, let's move on. Okay, rest on its denominator. Cannot have a radical in the denominator. We actually skipped ahead in one class in this and already started talking about this. You can't just multiply by the same radical. You got to multiply the top and bottom of the fraction by whatever it takes to make the perfect nth root. And that's why it's important to have that nth root chart memorized, okay? Because this isn't something you can just put in the calculator. You kind of have to know which numbers you need to find to get the nth root. Okay? So on this one, we have 1 over the cube root of 2. Now, cube root of 2 is not a perfect cube, but what is a perfect cube? That when you think about the perfect cube list, you think about, 2 cubed is 8. So if I can get it to 8, I know 8 is a perfect cube, so that's what I'm going to try and get it to. So what times 2 equals 8? It's 4. So I'm going to multiply by cube root of 4 over cube root of 4. Okay, so on top I'd have cube root of 4. On bottom, 4 times 2 is 8, so I'd have a cube root of 8. Then I can simplify that. It'd be the cube root of 4 over, what's the cube root of 8 is 2. And that would be my answer, and I've rationalized the denominator. Okay, that's kind of how you have to go about that. Let's look at the second one. You got the cube root of, I'm going to split it apart. We got the cube root of 2 over the cube root of 9. Okay, now 9 is not a perfect cube, but if I start making a perfect cube list, okay, I know 2 cubed is 8. I know 3 cubed is 27. So what am I going to multiply 9 by to get 27? I'm going to multiply it by 3. So I got to multiply the top and the bottom by the cube root of 3. Okay, so when I multiply the top by cube root of 3, cube root of 2 times cube root of 3 is cube root of 6 over cube root of 27. 9 times 3 is 27. Then from there, I can't simplify the top. Cube root of 6, I can't simplify it further. But the cube root of 27 is 3, and I can leave it like that. Okay, so basically on those, you have to look at those perfect cubes to make it simplify. Okay. Add and subtract the radicals. You must have the exact same radicals in order to add or subtract the coefficients of the radical-like terms. You may have to simplify radicals first in order to have the same radical. Okay. So, all right, so we got 4 through to 10 plus 7 4 through to 10. We can rewrite this as 1 4 through to 10 plus 7 4 through to 10 equals 8 4 through to 10. All you're going to do is add the coefficients out front. Okay, pretty easy, right? They both have 4 through to 10. You can add them. Okay. Now we got the cube root of 81 minus 24. Now 81 is not a perfect cube, but what goes into 81 that is a perfect cube? Well, 3 cubed is 27, so we can break down 27 into 1 times 27 equals 81, 3. And the cube root of 27 is 3, so we can write it as 3 cube root of 3. Minus, again, 24 is not a perfect cube. So what goes to make 24 that is a perfect cube? 8, right? 2 cubed is 8. So I can break it down into the cube root of 8, and what times 8 equals 24 is 3. So I'd have cube root of 8 is 2 times cube root of 3. Now they are both cube roots. Okay, so now they're both cube roots of 3. We can subtract them. 3 cube roots of 3 minus 2 cube roots of 3 equals 1 cube root of 3, or just cube root of 3. Okay. So you sometimes have to simplify, sometimes already be perfect, sometimes you have to simplify to be able to add and subtract. Okay. Simplify route expression with variables. Okay. Basically on this chart, what we have to think about is remember, there is an imaginary 2 right here. Okay, 2, 2, 2, 2, 2. Okay, so when we look at this, 2 divided by 2 is 1. Now, 2 divided by 2 is 1. 3 divided by 2 is 1, so you take 1 out, but whatever you have left over, the remainder, if you think about division as a remainder, you know, think about 3 over 2, 3 divided by 2 is 1, but you have 1 remainder, you leave the remainder underneath the radical. Okay, you think about the other one, 4 divided by 2 is 2. 5 divided by 2 is 2, but you have 1 remainder. 6 divided by 2 is 3, okay? And that's kind of how you have to go about it. It's basically divide, and then whatever you have as a remainder, you leave underneath the radical, okay? So look at this example. 5 divided by 3 is 1, but you have 2 left over, okay? So you leave the 2 underneath the radical with the same root sign. It's going to take some practice on this. So the first one, 64. Is 64 a perfect cube? Yes, it is. Cube root of 64 is 4. Okay, so you can just write 4, and then this goes evenly. 6 divided by 3 is 2, so 4y squared. Okay. The next one goes pretty evenly. We can split it apart into 4th root of n4 over 4th root of n8. 4 divided by 4 is 1, so n to the first. And 8 divided by 4 is 2, so n squared. We can leave it like that. That looks good. Okay. Now we go to the next one. 48, 4th root. 48 does not have a perfect 4th, or 48 is not a perfect 4th root. But if we look at perfect 4s, think about it. 2 to the 4th is 16, so I know that 16 goes into 48, so I can break that down into 4 through the 16 and 4 through the 3, because 16 times 3 equals 48. Okay, so the 4th root of 16 is 2, and then I have the 4th root of 3 right here. Okay, so that's how I write that first part. If it's just 4th root of 48, it'd be 2, 4th root of 3. But I'm leaving space for my letters. Okay, so then I have x. Now 8 divided by 4, which is 2. That goes evenly. Okay, so 8 divided by 4 is 2. Then I'm going to write an x squared on the outside and nothing on the inside. Okay. The next one, y to the 5th. Okay. So think about it. 5 divided by 4. How many times is 5 divided by 4 be 1 1/4? 4. How many times does 4 go into 5? Is 1 time. Okay. So I can, if 4 goes into 5 one time, I can take one y out. But how many y's do I have left over? If I think about 5 goes into 4 once, I have 1 left over, then I'm going to leave that leftover y in the radical. And then the last one, 12. Okay. 12 divided by 4 is easy. 12 divided by 4 is 3, so I can take all my z's out, and there's no remainders. And that's how I write that. Okay, 2x squared y is e cubed 4th root of 3y. So basically, anything that's left over, you put underneath the radical. But if it's all, or if you think about division as a remainder, if you have a remainder, anything that's a remainder, you leave underneath the radical. Let's keep going. Okay, cube root of 6. Cube root of 6 is not a perfect cube. It doesn't have any perfect cube factors, so you can just leave it like that. Okay, cube root of 6. The next one. Okay, we got 4. We got 4 and 3. You know, how many times does 3 go into 4? 3 goes into 4 once, so 4 divided by 3 is 1. How many x's do we have left over, though? If we do 4 divided by 3, we have 1 remainder. So we're going to leave that 1 remainder underneath the radical. So we have 1 x on the outside, 1 x on the inside. Let's go to the y's. 9 divided by 3 is 3. There are no remainders, so I'm just going to put my y3rd on the outside. Then we go to z's, okay? 14 divided by 3. How many times does 3 go into 14? 3 goes into 14 4 times to make 12. Okay, so 3 goes into 14 4 times. Okay, and then I have 2 remainders. So I'm going to leave my 2 remainders underneath the radical. So that's how I write that is xy cubed z to the 4th cube root of 6xz squared. Again, this is not easy. It'll take some practice. Okay, last one, I break it apart into the cube root of x and the cube root of y to the 8. Okay, now, I can't have a radical in the denominator, okay? And the easiest way to do this is to make it so that this number right here is divisible by 3. So what I have to do is, remember when we multiply exponents, we add them, so I have to multiply what number divides by 3 is 9. So I'm going to add 1 to 8 to make it 9, and then it'll divide. So what I have to do is multiply both sides by the cube root of y, or the top and bottom by the cube root of y, to the first. Okay, if you want to write the first, you can think about it that way. So on top, I'd have, since this is saying they both have cube root, it'd be the cube root of xy. We just put them both next to each other underneath the radical. On the bottom, I'd have the cube root of y to the 9, because 8 plus 1 is 9. Then I can simplify it as the cube root of xy equals 9 divided by 3 is y to the 3rd. And that would be my answer. Okay? So that's how you have to do it with letters, is you just want to make it add up to something divisible by the root. Okay? All right, so that's your exit slip. Email me if you have any questions. That is it.